I think so. What'd you say, Gavin?
PKU?
Yes, it's about.
We know you watch Bluey. I think we should watch.
It's okay if you watch Bluey.
That's PKU. It's.
Thank you.
Girls soccer senior night is tonight.
Cool.
Show up at 6:20 for the ceremony and 7 p.m. for the last home game of the season. Be there or be square.
That was corny.
That was interesting. That was interesting. Senior night, be there. Be square.
I will not be there.
So, what was I saying just before that?
We were talking about.
About the what? Oh yeah, the week. It's gonna be a good week. It's gonna be a good week. Next week we got a 4-day week. No school next Friday. Teacher work day.
Wait, actually?
Is the football team gonna win this Friday?
Yes. Yes.
We're gonna beat. No, Mansfield Senior hasn't won a game.
Yeah, they have. They're 1-6.
I thought they were 0-7.
They're 1-6. Just like what?
I believe.
Hey, we are projected to lose by 12, but that doesn't mean anything. We're projected to lose by
Never doubt the
36
heart,
over.
never doubt the resilience of the Worcester Generals.
I believe. I'm a general through and through. Mansfield Senior. I believe. Love all the red out there today. Supporting Norway. Supporting Norway. Super sad what happened there over the weekend. So far, I don't know if you've been paying attention, but we've kind of done notes 3 different ways. This will be our 3rd different way. Chapter 1 was like metrics. Chapter 2, we did a concept map, right? We did Kool-Aid notes, the Kool-Aid scale. What was that for?
Nothing. I'll just laugh back to fake leave.
And then chapter 3, what? I don't know what mind map is. Oh, like a concept map. Yeah, well, I made it for you. So chapter 3, I'm going to do something called 2-column notes. So here's why 2-column notes are kind of cool. Did you guys pick these up on the way in? So you will see on these that there are 2 columns. I know. Mind blown. I know. Now, here's the cool thing about this. If you fold, don't do this now, fold it back, you'll see that there's like a question on one side, and there's an answer on one side. So it's kind of like building flashcards.
What?
A good study tool for you guys to use as you're going through this. So, I did make this. So, chapter 3, you will see the first block says, name the 3 main points of the kinetic molecular theory. This is going to be the first thing in this class you must memorize not word for word, but pretty much. So we're going to review this, hit this every day for the next 2 weeks. So write this down, word for word. Number 1, everything's made of particles. All right? What? I would write the 1. Okay? So number 1, everything is made of particles. I'm summarizing. You guys can write the full thing or what I said. All right? All matter is made of atoms and molecules that act like particles, but everything's made of particles. That's what step 1 says. I'm going to hydrate. They also have to memorize this. They still have this memorized when they get to AP Chem with me junior, senior year.
Everything is made of particles.
Mm-hmm.
Did you know that?
I did know that. Now, if you know that everything is made of particles, you may know step 2 already.
Particles make up everything. Particles can't be destroyed. Compound.
Wait, how many are there?
There's 3 rules. What do particles do?
It makes us.
What'd you say, Joel? They move. In fact,
Constant motion.
particles are always moving. Particles are always in motion. The hotter, the faster. The colder, the slower.
Yeah, we did a gizmo on this one.
Done maybe something like this, all right? The hotter, the faster, the colder, the slower, which makes sense, right? If you heat up water molecules, what are they eventually going to do? Boil. If you cool them off, they're going to slow down until they become ice. Yes. So hotter the faster, colder the slower. So part 1, everything's made of particles. Part 2 is worth particles always in motion.
Thank you.
Hotter the faster, colder the slower. So that's 3 points so far. This whole thing is 4 points that you gotta remember. Part 3, what else could affect?
Excuse me?
Shh. Shh. What else could affect the speed of particles? Who here is on, anyone here on the football team? Okay, who is our wide receiver for the varsity team? Hayden?
Yeah, sure. Actually, no, he's not a wide out, but yeah, he's probably just
Julian Edelman.
Who is our largest offensive lineman?
Willie Cooper.
Hudson Coop.
Hudson Coop. Bro, doesn't.
On the varsity football team?
Brody Borman.
Brody Borman. If Brody Borman had a foot race with Hayden Meese, who would win?
Hayden Meese by like 40 seconds.
Why?
Because Hayden Meese runs a 4.340.
Why?
He's faster.
But part of, if we were, he's smaller. You got it.
Division I athlete.
So, that's number 3. You got it. The third thing that affects particle speeds, at the same temperature, more massive particles move slower, and less massive particles move faster. So those are the 3 main parts of the kinetic molecular theory. Number 1, particles always everything's made of particles. Number 2, particles are always moving. The hotter, the faster, the colder, the slower. Number 3, more massive particles move slower. Less massive particles move faster. So there's really 4 things you're saying within those 3 topics. 1, everything's made of particles. 2, they're always moving. 3, hotter the faster, colder the slower. And 4, more massive are slower and less massive are faster. Do you feel like that's something you can remember by next Friday? You can. Because this chapter moves pretty quick. A lot of this is review. You guys already know a lot of this stuff. We're not going to spend a lot of time on this chapter. This first part of the chapter is review, then we're going to go into the gas laws, which are new. We're going to go into the gas laws, which are going to be new to you. Okay, I'm going to wait for you guys to finish up writing.
Hey, did you see our Dover game?
I saw the score.
It was nice. It was a good game.
It was a good game up until the last little bit.
Huh?
Yeah, and one
It
of
was
the band members
28
passed out.
28 going into the fourth.
Good game.
Yeah, 28-20.
You guys see the Browns game?
Addison.
Yeah, I
Did you
watched
see the Upstate game?
Hey, Ohio State is one of like 2 teams that didn't get upset on Saturday.
Jeremiah
So,
Smith is dirty.
Alabama.
did you see that they took the goalpost
Yeah.
and they threw it in the river?
Yeah.
It was incredible.
That's like some Tennessee game.
Yeah.
Carried it like a mile.
All right, so
Vandy.
what does the next block say?
Roll Vandy.
What is the theory used to show?
What's the theory used to show? Yeah, states of matter. There are 3 common states of matter, which are solid, liquid, and gas. There's a 4th state,
Plasma.
plasma. All right? We're going to talk about plasma in a little bit. Maybe not today. 3 common states of matter are solid, liquid, and gas. Solid, liquid, and gas. So that's what this theory is used to show. What's that?
Is there more than 4 states of matter?
Not that we know of.
There could be.
How do you define this?
Our periodic table depends if we can like harvest like a meteorite or discover something else in the ocean. Like I still think we're gonna find more elements. I do. I think we'll find more elements.
What was the last one?
The last one, mine's a little old. I think we're past 118 now. I think we're past 118. That one's a little bit old. They're just really expensive to buy big periodic tables that size. So, what are the 3 common states of matter? Solid, liquid, gas. So far, we are talking like 6th grade. Actually, my daughter might know this. It might be like 2nd grade science. Solid, liquid, gas. So we're going to talk about the particles in all 3 of these states of matter. The first state is
Yeah.
gas. Look at that picture. Isn't that incredible? Like, this is on an oil rig, and why would you not do that? I'm just saying.
It pollutes the
Well, I mean, why would you not take that picture, though? I would. I'm just saying. Okay.
So you would kill atmosphere element.
No, that fire's happening either way. That wasn't like he did that just for that. What are the properties of a gas? What movie is this from?
Whoa.
No, Christmas Story. And what do they say? You'll shoot your eye out. Yeah, you got it. So I like to compare gas particles to 8th graders. Think about this. Number one, they're free to spread in all directions. Think about this. Where do we keep the 8th graders?
Upstairs.
Up in that little hallway. If we don't, where are they going to go? They're going to spread in all directions. Okay? They do. The 8th graders sometimes get out. All right? So number one, 8th graders, gases, are free to spread in all directions. Number two, there's little or no attraction between 8th graders. Gas molecules. All right? There's not a lot of relationships, 8th grade. And if they are, they're not real for the most part. What? Little or no attraction between the gas molecules. Molecules are not attracted. They're very spread out. Three, 8th graders, gas particles have no definite shape or volume. I don't know about that. That's kind of weird. But gases do not have a shape. They do not have a volume. Can they take the shape of a container?
Yeah.
They could. But there is no definite shape or volume. Right now, are there gases taking the shape of the container that we're in?
Yeah.
What is the shape of the gases in this room? It's a cube, right? It's a cube.
How many things is there?
I think 4 or 5. Gases can exert a pressure. Do 8th graders exert pressure on your nerves? Yes.
I hate 5th graders more though.
All right. 5th graders?
Oh yes. Anybody younger than me, I hate.
Oh, wow.
It's really annoying me.
You used to be a 5th grader and an 8th grader. I'm just reminding you that. Gases can exert a pressure. Gases can exert a pressure. Oh, that was it. Phew. Barely fit that. So that may lead you to a question.
What is pressure?
What's pressure? Yes. What is pressure? Pressure is the force per surface area, or the force per unit surface area. So if I'm ever solving for pressure, the equation would be force divided by area. The force per unit surface area. The more force you have over the smaller area, the more pressure.
Very distracting.
He actually waited. We made eye contact before
That's cute.
he
That's
sharpened it.
romantic.
No, it was just appropriate. Just, waiting for that break.
Oh, yeah. Nico's so cute.
All right, let's keep going.
That was so silly.
What is this a picture of on my screen?
Air freshener.
Helium.
Yes.
What are we mounting here?
That's not a lawnmower. That's a pressure tank. All right. Not a pressure washer. This is just an air pressure tank. Builds up pressure. Okay. On your own paper, can you write down an example of how a gas exerts a pressure? On your own paper. Try to come up with an idea. Shh. Write it down. If you can try to come up with your own example of how a gas exerts a pressure. Exert, like pushes or does or... Yeah, try to come up with your own example. You're on the next page?
No, it's the same page. I should have read there.
But the next page.
No. Oh, natural. Oh, totally. Oh, I thought you were being for real.
Luke, do you have an example?
Not really. Kind of lost.
I do.
Riel. Helium tank. Okay.
I got.
Gavin?
I don't know, filling a tire over there.
Filling a tire.
PSI.
Air pressure.
Nail gun.
Nail gun.
So I can fill a balloon, you can feel it.
Fill a balloon.
Fill up a propane tank.
Propane tank.
Like if you blow, you can feel the force of the blow.
Yeah. You ever put your hand out the window in a car?
Yes.
go like this. All right? And then a sign comes, you're like, oh, like, you know, you're scared because, like, you think you're going to, like, have your arm chopped off. You know you've done it.
No, I don't go.
Ava, you've done it.
No, I just go like
I don't put it.
Yeah, but, like, when that sign comes, you're like,
No, I just leave it. I don't really.
yeah.
I don't let it just.
Is there gas exerting a pressure on the sides of this balloon?
That's what I said.
Yes. There we go. There we go. That's kind of satisfying, in all honesty. I should just blow it up and let it go into Mr. Edwards' room.
Do it. Do it. Actually do it.
We're not like that yet. No, me and Mr. Edward, we're not like that yet.
Come on.
We're not like that
Yeah,
yet.
no, you can do
No.
it so much worse.
All right, listen.
You're gonna get like that. You never do it.
Listen, here's what I'm going to do. I'm going to put this balloon,
That's pressure right there.
I'm going to put this balloon right here. All right? Right there.
Yeah.
During the fourth quarter, if you remind me, I will do it.
Bro.
That's definitely not gonna be write something down.
I will leave that there until the fourth quarter.
No one's gonna remember you.
No, 'cause you're gonna see it.
Put in that dude's
Oh, there's
room.
some custodian here.
That's
Why would a custodian take that? That's there for a reason.
Project that
No.
happened to be by the yeah.
Put a sticky note.
No one's going to take that.
Oh, that's one girl.
I will put a sticky note
I'm gonna remember.
right now.
Put the sticky note on the TV.
Do not move. Please.
No, but you gotta put like.
Why would that fall?
I've seen much weirder things fall. Gavin, what are you talking about?
There we go.
Thank you.
Fourth quarter.
Wow,
That's you make it like stick from your own skin. Like, what if it just?
Now, all that stuff will die by then. So, all those examples are good. All those examples are good. Have you guys seen Up? Yeah?
Yeah.
Did you know that Up, Toy Story, and Inside Out are all related?
Yeah.
There's like
Yes, he does.
the Pixar conspiracy theories. I do watch those.
Oh, you have cheese balls.
Because why would I not, is the question.
The balls are always better when they're cheesy.
Why not? All right. So, did anybody see the guy who took the balloon to space, jumped out of the balloon without a parachute? This was like a Red Bull challenge, and he like went to the edge of space. The balloon keeps getting bigger, and then what was this guy's name? Baumgartner, Felix Baumgartner. Felix Baumgartner. Yeah, he jumped out of this vessel, and then the problem was he started tumbling. He started tumbling too fast and spinning, but then he recovered, and then he never opened his parachute. He had a big net that he landed in. He did it successfully. So.
He probably has like
How do you know where the net? Did you just like aim? Red Bull's guess where the net was gonna be.
Well, I mean, he could tell from where the ground was. He had like practiced going up there. The net was huge. If we have time, I'll show you. I'll show you the video at the end. Okay. Solid. Properties of a solid. So, solids are rigid. The molecules are way closer together. The molecules or the particles are still moving though. How are they moving? They're vibrating in place. How does that look? It kind of looks like, I don't know, imagine the cheese balls back there, right? They'd be like they'd just be like moving in place, like right there in place. If that was full, that'd be a really good example of a solid. I don't want to shake it because then it's going to crack the cheese balls. Nobody wants cracked cheese balls. What?
They're too filled with air, they probably crack.
No, I don't want to risk it. But this bag of popcorn, this would be a good example of a solid. All right. So here are my popcorn kernels are my particles, right? These particles are just kind of vibrating in place. Are they moving a lot? No. Is the shape changing? No. That's why they're solid. That's why they're solid. You like Jenny's? Yeah, Bueller's.
Can I get some?
Not right now. I don't think I have enough for everybody. It is good. Strong attractions for these. And solids have a definite shape and volume. Solids have a definite shape and volume. So your solids are the exact opposite of your gases. Gases, no shape and volume, no attraction. Solids, definite shape and volume. Strong attraction. Particles vibrate in place, particles free to spread. They're the exact opposite. So those are properties of a solid. Can I keep going?
No.
Okay, I'll pause. I'll hydrate while you guys are.
No, you can keep going.
Keep hydrating.
Shotgun it.
Yeah, that's metal. A liquid. A liquid. I want you guys to be thinking while I'm giving you these properties of a place in the school that would be a good example of a liquid. Not yet. Not the swimming pool, all right? You're right. That's a literal place. I'm thinking of a more figurative place. So let me give you the properties, and then you guys see if you can come up with a place in the school where this would be happening. Particles are close to each other, or they slide past. All right? So the particles are moving, but they're sliding past each other, first of all. There's a weak attraction between the molecules. So not strong, not weak. They're just trying to kind of get by. And liquids take the shape of their containers. Liquids take the shape of their containers. Is someone going to remember fourth quarter to do the balloon?
What if he gets the idea before you? What if he like does it?
Why would he get the idea
Because
before
if he had
me?
it- It's kind of like the idea of like, you know, like if you give a chimpanzee a typewriter, eventually they might type the words of
How does that have
Shakespeare.
anything to do with this cult?
Yeah, I get that.
Technically, he's not
My
alive
typewriter
right
computer.
now.
Can anybody think of a place in the school? Who said it? The hallway. Yes.
I was thinking like
Have you guys ever been in the hallway down here by like Mrs. Arnold's room? There's the stairs coming down from lunch, this hallway down here, and there's like a four-way intersection, right?
Oh, that place is terrible.
It's the worst hallway in the building. What are you trying to do in that hallway? You're just trying to slide past.
it's low-key not that bad.
It's pretty packed at certain times of the day. After lunch, before lunch, like
I'm not there.
it's full. The hallway right down here, where the stairs come down, it's where people go out to the buses. You can go back to the band room or this way towards my room.
Mr. Heller down front.
What, you call me Mr. Feller? Anyways, when you are in that hallway, there's no attraction, all right? You are just trying to get by, and you actually probably will bump into somebody. All right, you probably will bump into somebody unless you like do like ninja moves. Like I do that sometimes. Huh? You know, you got like. See, look at my back. My back's so good. I could have done that on Friday. Friday, I was like, oh.
You know me, I swing through the hole.
What, you swing like Spider-Man?
Yeah, he like throws on the ceiling like upside down.
That'd be cool.
Like he actually does.
You know me. He's invisible.
Okay. What is the next question on your paper?
What are fluids?
Okay, what is a fluid? Anybody think they know what a fluid is? What? That's true,
The amount of a liquid.
but that's not what a fluid is.
A liquid in it.
A liquid is a fluid, but that's not the definition of a fluid.
A fluid is a liquid that's not a pure substance.
No.
No.
It sounded very official, though. It did sound very official. Any other ideas of what a fluid is? My best definition of a fluid is fluids can flow. Nice. All right, fluids flow. So, liquids are fluids, but so are gases. Gases definitely flow. How do fluids flow? Anybody know?
With weak attraction.
They flow from high areas of pressure to lower areas of pressure. So, if somebody in this corner of the room lets out some gas, guess where it's going to flow? Towards that area of the room. All right, it's going to flow towards that area of the room because there's less particles there. If you poke a hole in a bottle, where's the water going to flow? Out the hole, right? Because there is less water where? Outside of the bottle than in the bottle. So fluids want to flow.
What if it was in a pool?
In a pool? Have you guys ever seen those movies of people that are like taking their pools apart and just like goes crazy, like they surf the water down?
Oh yeah.
Those are cool. Is this supposed to happen, or is that like busting their pool?
No, that's busting their pool.
What? It busts? Okay. Well, it looks really fun
You
though.
should just use like a hose.
Yeah, I would probably just like siphon it out and then just let it flow.
Well, if you like put it down to a certain amount, then you put the cover on, then it like just like evaporates.
Yeah, that works too. So fluids flow. We measure fluids, their rate of flow by what? Viscosity. So viscosity is the resistance of a fluid to flow. The thicker the fluid, the more viscous it is. So if it is thick, it is viscous. If it is thick, it is viscous. Does the next one say rank 3 things from least to most viscous?
Yeah.
So do that on your own. It says rank the following from, does it say least to most or most to least? So on your own paper, make your best guess. What is it? Honey? What are the 3 options? Water, oil, honey, and rubbing alcohol. Rank those from least viscous to most viscous. Least viscous to most viscous. Can somebody think of something else that's really viscous besides honey? What's the example you usually think of? Molasses. Have you guys ever had warm molasses on a bread, like on a roll?
Is it butter?
It's pretty much thick sugar.
Molasses is just like thick sugar.
I always think of
Anyone here ever been to a Lambert's? So Lambert's is a restaurant. There's like 2 or 3 in the United States. The one I've been to is in Arkansas. I've been there twice.
I've been there.
And what do they do at Lambert's?
They throw rolls.
Yes, they throw rolls. That's incredible. Lambert's is the home of the thrown roll.
What did you just chuck on the table? It was so.
The servers come out and they've got warm rolls
You just raise your hand.
and they just throw them and you just catch rolls. It's incredible. They're huge rolls and they've got this like honey dipper with molasses. How big? Oh, they're like big. Like the rolls are, they're not softball size, but like baseball size.
Are they as good as Roadhouse rolls?
Yeah. They're as good as Texas Roadhouse, but they're different.
Yeah.
Because they're more like bready. Like Texas Roadhouse are more doughy. You know what I'm saying, Nick? Yeah. It's hard to describe. But these rolls, the person brings out this big pan of rolls and he just goes shoom, 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 and he just throws these rolls. Then if somebody brings out the molasses dipper and they will dip the, like, just let molasses drizzle over your roll. Oh, it's so good. It's so good. It's the only place I've ever had molasses is at a Lambert's.
I had like shrimp. Like shrimp and steak.
Yeah, and then they have all these sides, and they bring out all the sides like collard greens and corn.
Course is bread.
No, the main course is like,
That's what they're known for, though.
they're known for their thrown rolls.
Like that.
So it literally says like the home of the thrown roll.
Where'd you get
So what if you drop it? Arkansas.
If you drop it, they throw you another one. Yeah.
Or just grow?
There are roll patrollers. You know the people that follow the horses in parade, like the poop people? They got that for like rolls. They just brush them into a, no, they do.
Or you could just grow up here and eat
Um,
anyway.
Why? Why do you have to talk like that? It's just like, why?
Where'd you grow here, dude?
Um, okay, viscosity, what'd you guys say? How'd you rank it?
Rubbing alcohol, oil.
Rubbing alcohol, oil,
That is not.
honey.
I got that spot on.
Honey would definitely be the thickest of all of those. Oil, I would say, is less viscous than rubbing alcohol. I'm sorry, less viscous than oil. Whatever. You know what I'm saying? Honey. I'm still thinking about bread. I'm still thinking of thrown rolls. I've been to Lambert's, I think, 2 or 3 times in my life, at least 2. So good.
Wait, is there only,
There's also one down in the Gulf Coast between like Texas and Florida somewhere. There's 2 Lamberts.
where is it?
Where is it?
Texas and Florida, wouldn't that make it Louisiana?
I don't know.
Isn't it where there's like a big like something that's known for like?
Yeah, it's down by New Orleans, I think. I think it might be. Do we have one more left on this page? Let's do this. I'm going to pull up the video of Felix Baumgartner jumping out. What is energy? Well, here's the thing. This is the thing that you guys always lie about. Because you wake up in the morning and you say what? I have no energy. All right? But you do. Why? Anybody know the definition of energy?
You just have.
Nope.
You're awake.
You have ability to work.
Boom. How do you know this?
It's on the screen.
Yeah, it's just the ability. Yeah, you're right. It was right here. All right? Energy is just the ability to do work. So you have the ability. The question is, do you want to convert it from potential to kinetic? The hardest part for me is making my potential energy when I'm laying in my bed turn into kinetic energy to get out of bed and get moving.
You set your alarm like away from the bed so you can get up.
I set it for 6:26 and I hit the snooze.
26.
Yeah. I go like this. I spin my alarm at the beginning of every school year, and then I have a new alarm every year.
A new alarm.
As long as it's between 6 and 6:30, I spin it, and that's when I wake up for the year.
Oh, wow.
So this year's a later wake up time. It keeps it fresh.
What is it?
6:26 this year. Last year I woke up at 6:17, I think. If you wake up at 6:05, lots of snooze is possible. Just saying. What?
You wake up.
6:01.
I still have time to take a shower. 6:26.
Bro, please stop. You're making me laugh.
I don't have to be here till 7:15. All right.